Perfect. Hello, welcome to the talk, Creating Elegant Builds at Scale with Gradle. My name is Dockter. I'm the founder of Gradle and the CEO of Gradleware, the company behind Gradle. And when we talk about scalability and builds, actually there are quite a few dimensions that are relevant for scale. It's performance, it's how can you hide the complexity to the normal developers, it's dependency management, and quite a few more. So I will talk about some of those scalability dimensions when it comes to build and continuous integration, continuous delivery pipelines. So before I go into that, I just want to talk a little bit about what I think is the state of our industry when it comes to building and shipping software. So as part, one thing we do with Gradleware, we do a lot of consulting around continuous delivery, build, continuous integration. So we are involved with many enterprise software stacks, including some of the largest software stacks on the planet. So we have quite a bit of insight into what is going on, and the reality for most organizations that have larger software stacks at least is that the feedback cycles are way too long, the degree of automation is low, the quality of service of the build and delivery pipeline is not very good. Often there are problems with the quality of the shipped software, and the time to market of features is way too long. And that is where one of our major focus is, right, and always has been. It's the medium to large software stacks and the problems they have. So, and we think that our industry is at the beginning of a revolution similar to what the car industry has seen in the 90s with lean production. And we want to be, or we consider ourselves that we want to drive that, right? So it's always interesting how people can get accustomed to pain, and we see a lot of pain in our domain. And I mean, you might have a positive perspective on that. You could see, well, I can see with one eye, and I still can breathe a little bit, right? So, but that won't help you much if you have that pain with your build and with your CI, because the pain is going to increase. So one thing is that the software code bases, they're growing and growing. So we see typical growth rates for some of the large software stacks we're involved with between 20 and 100% per year. So with such growth rates, even with 20%, right, you have your code base is twice as big in 4 years. So when you have, let's say, build times of 5 hours, right, and you have distributed teams, in 4 years you will have build times of 10 hours, and then your system will collapse, for example. And that is what most of the organizations are facing as software is eating the world, basically. And the growth rates also usually means you have more and more people in your team. So, which means the inefficiencies you have, they will become more and more costly to you. The other thing that is happening is that your software stack is increasingly more complex. So 7 years ago, a company could have said, we are a Java shop, right? Those times are over. You now at least Java, iOS, and Android, and most likely also JavaScript and some native code. So the heterogeneity of the code bases is a reality that is increasing more and more. And traditionally, build systems have been designed around a certain software platform, and that is not working anymore. So there's a lot of complexity you get from that side. The other changes you see is the architectural change towards a microservice design, which makes definitely continuous delivery more challenging. And that's another dimension of complexity. And the only way to solve that is to have a true multi-platform build system, right? That's our opinion. And it's interesting to look at some of the organizations who are very successful in shipping their software and very efficient. One of them is LinkedIn, one of the large Gradle users. They have they have 1,000 people built, right? 4,000 submodules they're doing with Gradle, and they invested a lot into improving their delivery capability. So if you look at LinkedIn in 2011, it took them 30 days to ship a new version of their software. Do you think this is good or this is bad compared to other organizations of that scale? So who thinks this is already pretty decent? Right? Yeah. So I think it was way above even current industry average, considering a team at that time of 500-600 developers shipping one stack, right? So, but if you look at that number, releasing every 30 days means once you have a feature completed, it sits 15 days in the shelf. You have an inventory term of 15 days. What they have achieved in 2013, and they're still improving it, is they're now able to do 2 releases per day, right? And they now have 1,000 developers. So that means they have increased their inventory term by reduced it by a factor of 30. This is revolutionary. This is a massive, massive improvement. And think now that you're competing with LinkedIn, right, as another organization. You would now have a serious competitive disadvantage if you're not able to do the same. And that's another reason why companies have to invest. At the moment, quite a few organizations can get by with a very inefficient process because their competitors are not doing better. But this is going to change, right? Okay, so another thing I want to quickly talk about is the momentum of the Gradle technology. So when you introduce a technology in such a critical infrastructure space as build, like changing a build for a team of 50, 100,000 people, you're not just interested in the features of the technology, people are usually very conservative in terms of what is the future of that technology, how safe is it to bet on that technology, right? So people want to be sure that a new build technology is around in 10 or 15 years. This is often the lifespan of the technologies we are replacing, and people want to be sure that the problems they have been successfully solved with the same technology somewhere else. So the threshold of entry in this market is very high, right? So there has been an armada of new build tools, but in terms of having traction in the enterprises of all the new build tools, there's only one, that is Gradle. Until the middle of the year, we had just in this year 2 million downloads, right? So if you look at Google Trends, that is what Google Trends is saying about Gradle. So you see very, very, very strong dynamic. And even if you go compare it with other well-known technologies like Cloudera, you see there's a lot of substance in there. So even if you compare it with Hadoop, we're now at 30% of the Hadoop value for Google Trends. So many books are out there for Gradle. There was an interesting survey by the JRebel folks asking what technologies are developers most interested in, Java developers. They asked 2,000 Java developers, and from all the technologies in technology space, Gradle was the technology where developers said we want to learn more about. So I guess that's why you're here. So let's get started. So one very important aspect of dealing with scale is how easy is it to describe and specify the reality of your software stack, right? And Gradle has introduced some very powerful concepts, components and variants. Some of that is brand new, right? It's just in master and it's still incubating, but and I want to talk about that. So one thing, talking about being a multi-platform build system, those are platforms that are either already true first-class citizen in a Gradle land, or we are working on making them first-class citizens, right? So Gradle is not a Java build system where you somehow squeeze in some CC++. They're completely on equal footing with the same support. That is our approach, and I think that is crucial for modern enterprise software stacks. So if you look at this is the workflow to ship even a simple Android application. So Java, in terms of continuous delivery, is one of the simpler domains. It still has a lot of complexity once you have a larger stack, but some domains, Android and even more so CC++, are much more challenging. So there's a lot of complexity in the Android world, and I just want to show you how we model this this world so that you can efficiently deal with this complexity. Okay. So why is the application switching not working? I don't know. Sorry. Here we go. Okay, so let's start with a simple Android application. So you just say in Gradle, hey, can you read that in the last row? Thank you. So you just say, hey, Gradle, this is an Android application, right? And then you specify, what version of the SDK you want to use and what not. And then that's all you need to say. And then Gradle basically provides you a full life cycle of building an Android application, right? Compiling, dexing, signing, integration testing, and all the other stuff you need to do. So in that respect, you could say, okay, I know a build system that provides me a similar experience. You just say, I have this type of project and I have a life cycle, right? That would be that's a kind of Maven-like story. So, but this is getting already a little bit more interesting. So one thing that is modeled for Android is the concept of a build type, right? So, and that is also a concept we see in Java, we see in the native world. You not just have one binary when you build a component, right? That is a very limited model. So what you very often have, definitely in the Android world, is that you have build types, at least something like a debug variant of the binary and a release variant of the binary. And that is already baked in, right? So with other build systems, you have to kind of hack around this with profiles. Here, this is a built-in concept, right? And you can then easily say, build me all binaries, right, for release and debug. Just build me the debug one, just build me the release one, and can elegantly also configure what needs to be done during those, for those different build types. Those are model types, right? So they have properties. A build type has certain properties, and the release build type has different properties than the debug build types usually. Okay, so that is the first example, how you can hide quite a bit of complexity behind a high-level language. Now let's do something a little bit more interesting. So a typical problems Android developers are facing very often is that they have other variants of their component, of their application, right? They have one application and then they have slight variations between the paid and the free version, or they have slight variations between ARM and x86. You all heard one of the problems in the Android world is fragmentation, right? And that is basically a key answer to that. And even if you look in the iOS world, you have now quite a bit of fragmentation. So how can you deal with it from a developer tooling perspective, right? So you can't just say, hey, this is an Android application and then you impose a certain view of the world that is very hard to change, right? On the other hand, the alternative would be go back to the end days where you have a very flexible but very low level build language where you can do everything but things get easily out of hand, right? So the Gradle, the approach Gradle is taking, saying declarative builds are super important, but we need to have more fine-grained elements than just say this is an Android project. So what you can do, for example, in Gradle, you can say, okay, I have certain product flavors. That's how it's called. I have a free product flavor and a paid product flavor. And you, as the developers, you define that. You use this high-level language to describe the reality of what you're trying to do. And then you have, once you say you have a free flavor, right? You have a convention in place that if you put stuff now in source free, right, this will be the code, or in source paid, this will be the code that is only added to that variant of the binary automatically, right? So, and then you can have different dimensions of flavor. So one is the version, free versus paid. One is the binary interface, ARM x86, and that is all you need to specify. And including that you have conventions for the test. So as soon as you put some tests into Android test paid, those tests are very specific only to the paid version. All the tests in Android tests, they will be executed against every binary, etc., etc. So if you, it's now pretty interesting to look how many tasks you will get out of that, right? More than 300 tasks. Imagine you would have to write such a build with AND. You would have thousands and thousands lines of XML, right? Imagine you would write this build I've just shown with Maven. You would easily end up with 30 or 40 subprojects, right? So there is a lot of complexity behind such a pretty simple spec I've just shown you, and the art basically is to find a sweet spot between flexibility and structure, so that you give enough flexibility to the developers to describe the common scenarios of their domain, but provide enough structure and abstractions that you don't expose them to unnecessary complexity. That is one example. And so it's all about, and that is at the heart of the Gradle effort, having a rich model. And one part of the rich model is the developers shouldn't think about how can I translate my requirement into the language of the build system. It should be the other way around. The build system should provide a language for the developer that the developer can describe the domain in his or her domain terms, and then the build system translates that into the terms of the build system, right? So that is key for having a low learning curve for developers. That is key for having maintainable and readable builds. But it's also key for a couple of other things. Having a rich model provides you two more things. One is it can provide you a really deep IDE integration experience, and second, it provides you a powerful way to easily extend your build with your own requirements. To give you an example, if you want to extend your Android build with functionality that basically for all your Android projects across the organization, you want to write a plugin that checks these Android builds, and if there is a free variant, you want to check all the dependencies of the free variant, whether there's any license violation, right? Whether all the libraries the free variant is using, let's say, non-commercial dependencies, right? Imagine you would have described what I've just shown you in an end build. There's no way you can ask an end build, hey, end build, what variants do you have? Or what build flavors product flavors do you have? And only knows targets. I have no idea what you're talking about, right? So it would be very hard to extend your build with such functionality, because there is no way you can ask this build certain questions. The same is true if you would model that with a Maven build. Maven says, I have no idea what product flavors are, I only have sub-projects, right? So for extending a build, it's key that you have a rich model that provides you an API that you can query to do your extension. And another key aspect of that is also deep IDE integration, and that is the next thing I want to show you. Oops, that's... So here we have, I'm now in Android Studio, and we have a simple Android application, right? And this Android application, I show you the build script. I just defined two product flavors. Make it a bit bigger. Free and paid. That's all what I needed to do. And then I've created a source free directory with some resources and a source paid directory with some resources. And because this is now richly modeled, it's very easy for Android Studio to offer you a view where you can choose your build variant, right? It can just query the build, hey, what product flavors do you have, right? And what build types do you have? And then you have a free debug, free release, paid debug, paid release, Cartesian product of variants, right? And if I now change to paid debug, what you can see, can you read that in the last line? Right? The IDE tells the build system, hey, the flavor has changed. The build system does all the necessary resource processing under the hood, and then automatically the view is updated, right? And that also gives you very powerful capabilities to extend the IDE, right? So you could now easily write custom logic. Let's say if you want to show some dynamic views where you have complex resource processing and resource generation, you can now easily do this in your build, right? And because this is now so deeply integrated with Android Studio, this is a way you can extend the behavior of your IDE, if you know what I mean. So Android Studio is a wonderful example, I think, where IDEs should be moving to, right? A key reason why Android moved to Gradle was that they didn't want to maintain two build systems. One build system for the Eclipse Android plugin, and the other build system based on Ant. They want to have one and deeply integrate that with the IDE. And there's more stuff we're going to do in this area. So, for example, another good example for that will be integration testing. That when you execute your tests from the IDE, they are actually executed via the build system, right? Including all the test fixture that needs to be set up, but you have the same rich visualization you are used to have when executing unit tests from the IDE. The visual runner, the progress indicator, red, green bars, and things like that. Right? So there's a lot of power when you have a rich model, what you can do with IDE integration. Also at your organization. Gradle makes it very easy for you to extend the language for your custom requirements, right? So if you, for example, say, oh, we need to model, so for our integration tests, we need to be able to run them on different servers, right? You could easily add a language element server where you can specify different types of server you have, and then you could write an Eclipse or IntelliJ extension that queries the Gradle build. Hey, what servers do you have? And provides the developer a drop-down menu where they can choose which servers to set up. The IDE just visualizes and then delegates the execution to Gradle, right? So you can have a very lightweight IDE integration, and all the build action is done by Gradle. Another positive aspect of that is that the behavior, the feedback you get from the IDE is 100% the same than what you get from CI. Okay, so that was Android. Now, Java. We are working on our kind of next generation Java support, and Java has been pretty simple in terms of building because there was not so much movement. Now things getting a little bit more interesting, right? So people have now, for example, more and more the problem that they need to develop the same component for multiple Java platforms, right? So, and I find it quite painful to set this up in the builds. And here is how you can do this now with the latest Gradle, right? You can just say, okay, I have a component called mylib, right? And it's a JVM library, and I want to build it for the target platforms Java 6 and Java 8. That's all that you need to do. If you now ask Gradle for some report, right? It shows you, okay, you have a JVM library defined, mylib, right? And it has two binaries, Java 6 mylibjar and Java 8 mylibjar. And so you have a very nice model of what you're trying to do, and you can now easily say, okay, build me all variants, right, for my component mylib. And now automatically Java 6 mylibjar is built and Java 8 mylibjar is built. So we will improve this to a point where we automatically will provision the JDK runtimes if they're not installed. Another thing we are working on, so I really like the latest Jigsaw spec, right? So one thing we will also soon start modeling for a Java component is that a Java component can have an API and an implementation, right? And we make it very easy for you to model this whether the API and implementation is in the same physical source directory doesn't matter, but you can logically model that, and we will then enforce that other components, when they have a dependency on your components, only use the API, right? So you get some feelings of Jigsaw even before Jigsaw is out, at least during build time. So yeah, there's a lot of exciting stuff we can do on the Java side of things to make that easier. And another important part is dependency management. So quite a few people have now problems. They need to ship a component for Java, let's say for Java 7 and Java 8, right? And those variants have different dependencies. Java 7 wants to use some retro libraries, right, to make use of some of the Java 8 features, and they potentially have a completely different transitive graph of dependencies, right? And there is no easy way to model that, right? There's no way you can properly model that with a POM. Classifiers are not good enough for that because because classifiers can't have different dependencies. So that is another thing we're working on: a variant-aware dependency management, right? That when when you say I have a component foo that depends on a component bar, and you want to build the Java 7 variant of foo, then it automatically will get the Java 7 variant of bar. And if bar has dependencies, it will get the Java 7 variant of those dependencies. For Groovy, this will be very cool, right? So because Groovy has also a variant challenge in terms of what was the compiler, the Groovy version you used to compile your Groovy binary, because Groovy, you can't necessarily switch the same binary for different Groovy versions. Scala has the same problems. So it's another thing we will soon be able to support. So that's pretty cool stuff. So C++, the most challenging of all build domains. So Gradle has grown into an extremely capable C++ build tool. By the way, a lot of Android developers need to write native extensions, right, via the Android NDK. So and the Android build system will soon switch from a make-based support for native extensions of Android to the Gradle C++ plugin. So at that point, Gradle will be one of the most used C++ build systems that are around. I don't have the time to dive to give many demos on that, but C++ is the most complex of domains, right? You have multiple platforms you want to support. You have build types, right? And you want to make it very easy to express. I have my executable, I have my library, I have shared libraries, I have static libraries describing dependencies between those things. Another super interesting concept in the C++ world and super important is the toolchain, right? You have very different toolchains to create your binaries, right? And this is fully modeled in the Gradle world. So, and then you can do things like, if you're using a GCC toolchains, you want to do certain configuration. If you're using a Visual CP toolchain, you want to do another configuration. But again, this concept is also very cool to have in a Java world. I'll give you an example. Let's say Jigsaw comes out, right? And you want to introduce Jigsaw in your organization. What you will be able to do with Gradle is to say, okay, I want to build for Java 9, and I want to build with two different toolchains. I have two different variants. One is building Java 9 with a normal class path and a normal jar. And then I define another Java 9 variant with a different toolchain where I use the module path of Jigsaw, right? And this will be super straightforward to model and will make it so much easier to start playing around with those technologies in a production branch. Okay. Finally, the whole idea of component is something that is open in in Gradle, so it will be, a Gradle plugin will be a component, a Grails plugin will be a component. We now started to provide support for Scala Blade. That's another component type, and you can enhance that easily for whatever you want to model as a component in your organization. It's a very powerful concept, much richer than to say this is a project, right? Project is a pretty superficial abstraction. We think component is a much deeper abstraction and super helpful for dealing with the complexity. So one thing we see, we basically see two types of organizations, right? So one is they let's say they're using and they never wanted to switch to Maven because they want to have the flexibility to model all the requirements they have. And what they ended up with is they have a pretty high degree of automation, but the build has become extremely complex, and not just complex for the build master, but even for a normal developer, right? They have build wiki pages, 50 build wiki pages, and developers are exposed to a lot of complexity to get their stuff done, right? And then you have the other type where they have extremely simple builds, right? Let's say a Maven build, which is super hard to extend. So they have a lot of simplicity, but a very low degree of automation. And so it's simple for the developer to use, but a lot of stuff is not automated. So that's also not a very good deal. And what we are trying to accomplish with all those concepts is the build master, they can sweat, they can have a hard time. It's a complex domain to model. But one of the key things they need to achieve is that the developers have a very high degree of automation for their workflows, and at the same time are not exposed to unnecessary complexity, right? So another topic I love to talk about is dependency management, right? So we see a lot of things that can be improved in that area. So first of all, Gradle fully supports POM and Ivy, right? Gradle can consume POMs, Gradle can publish POMs, consume Ivy XML, publish Ivy XML, but we have our very own dependency resolution engine, right? For us, those are just metadata formats. And you can do some interesting stuff. So let's look at a very simple project. So here we have a Java project where we have two compile dependencies, JSON token and wiremock. So now let's go here and ask Gradle, hey, show me your dependencies report. Oops. Oh yeah, that is. Okay, let's do it. No, let's do it like this. Can you see this in the last row? So one interesting thing here that you can see is we have Google Collections, right? And we have Google Guava. Both will end up on our class path. Yuck. That shouldn't be the case, right? So what to do? What do you want to be able to do now? Well, you kind of want to tell Gradle, hey Gradle, Guava has replaced Google Collections, right? Let's see if we can do that. So you can tell Gradle, hey, com Google Collections, blah, 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 is replaced by com Google Guava. And if you now run the same report, you will see that this JSON token library has declared a dependency on Google's collection, but this dependency is now replaced with Guava. Because wiremock has introduced Guava as a dependency. If you would get wiremock out of the game, you still have Google Collections in your transitive graph, right? So that's a pretty cool feature. I mean, every organization has this problem, and then they have to deal somehow with excludes. But this is not a proper solution to say I exclude Google Collections, because if you have a library, if you have a transitive graph where there is no Guava, you want to have Google Collections, right? So so we see a lot of fragility with the class So there are way too many situations. Yes, please.
Right now you're specifying it in your build file.
Yes.
But I would prefer specifying it in my repository.
Of course, yes. So that is a very good point, and I would have made that later. This is just for demo purposes. I don't want that the developers go to a build wiki and say, apply this. So what you would do, you would put this section, modules, into a plugin in your repository, into a Gradle plugin, and then apply this to all your projects. So you can have wonderfully centralized dependency management for your organization, where this is centralized information. Yeah, we see a lot of brittle class path issues, right? Where things are working because you're somehow lucky that the class path is in the right order. And then someone is doing some refactoring of the POM, and then boom, the class path is in the wrong order, and the thing explodes, right? And that is not a situation you want to be in. You want to be very explicit. You want to have powerful ways to model the reality of your dependency management world. And so substitution is a key concept. And it's interesting, if you look at the Jigsaw spec, that's something they also model, the concept of substitution, that a module gets replaced at one point by another module, right? And we think that that's a very important concept. So another thing you want to be able to model is the concept of a releasable unit. So for example, JBoss rules, JBoss rules consists of, I don't know, 10 different libraries, and you have to use the same version of those libraries, right? You can't mix and match those libraries. And it would be super easy in Gradle to express that fact, to say, hey, if you have dependencies from a certain group, they all must use one particular version. Whatever is written in the transitive graph by the transitive dependencies, you prescribe a version, right?
You can omit the version from the declaration.
Pardon me?
And then you can omit the version from the declaration.
You can omit it or you can put it in, but this will be enforced, right? Yes. So another interesting powerful feature are selection rules we have introduced in the latest Gradle release. That's pretty exciting stuff. So let's look at the following build. So let's say you want to have the latest JUnit dependency, 4.plus, right? So let's get our report going. And what you see is the latest JUnit 4 dependency is 4.12-beta-3. Okay, now you say, damn, I don't want to have any betas, right? So how can you tell this to Gradle? So what you can do with Gradle, you can specify what we call component selection rules. So you can say, for modules of type with the name or with the path JUnit, you can say if the candidate, the version of the candidate contains the term -beta, then select that version, right? So let's see what is happening now. And here we go. Now you have 4.11, right, which is the latest non-beta. You can now also, you can say, okay, I don't want to, this is not just my rule for JUnit, right? I want to do this, I want to specify this for all my components, right? So you can say, for all components, if the version contains beta, select this version, right? And you see, this should be still working. We still get JUnit 4.11. You can now also do other stuff. You can say, we have a particular issue with JUnit 4.11. We can't use JUnit 4.11. There is a bug in that release, so this is not working for us. And you can say now, okay, for JUnit, if the candidate version is equals 4.11, selection reject known bad version. And if you know, look at the report, you now get JUnit 4.10. And again, referring to your questions, this is just for demo purposes. You don't want to do this in your build script. You want to do this in a centralized place. And this is so powerful because you can now define different selection rules for different build types, right? You can have a selection rule for the dev build, where you're happy with all the beta and the snapshot versions. You can have a selection rule for QA, where you say, I reject all candidates that are not that haven't been promoted to QA. You can have different rules for release. This is extremely, extremely powerful to model different stages of your pipeline to get the right dependencies into your transitive graph. Right? It's a big pain we see with many organizations where they have teams manually changing always all the POMs they have once they promote a library. Right? So I love that feature, and we're working on it to continuously enhance our capabilities. You can even do stuff, right, with component selection that you can say that you can even take other metadata into account. So you can say if the component was published from a branch testing, or if some metadata status of the component is milestone or whatnot, take this also into account when you select a particular version, right? So you can assign your own metadata to components depending on how you want to model your staging process, and you can now make this a first-class citizen of the resolution process. Okay, there are other. The whole Gradle plugin ecosystem is very rich, and especially in the area of dependency management, there are some really cool external plugins out there. So Netflix has contributed quite a few. Who of you knows Bundler? Right. So one thing Bundler offers is that you can lock down your dependency graph. So what Netflix wants to do, they have the following workflow. When the developers start work in the morning, they use a lot. They use dynamic dependencies a lot. The first thing they do in the morning is to say, give me all the latest dependencies, right? And then with the dependency lock plugin, they lock the resolution process down, right, into a log file. And for the rest of the day, they tell Gradle not to get the latest, but use the same versions that have been resolved in the morning, so that they have no disruption during the day, right? So and you can commit log files into version control. So log files are a super interesting tool to find a good compromise between using snapshot-like dependencies and still being able to reproduce a certain build, right? And not they will evolve at one point into a core concept in Gradle, but at the moment there's a really good Netflix plugin out there that provides you with this functionality. Another interesting plugin that is out there is a blacklist whitelist plugin, right? So the whole Gradle dependency API is very easy to use for abstractions on top. So what this Netflix plugin is doing, you can put dependencies on a blacklist, right? You can say this particular dependencies is blacklisted, this particular version of a dependency is blacklisted, and then you can say if this blacklisted dependency is used, issue a warning, or you can say if another blacklisted dependency is used, let the build fail, and things like that. So again, powerful functionality to model dependency management challenges in the enterprise. So I wouldn't know any other resolution engine that even comes close to what you can do here. And again, we investing a lot in making this better and better. I've talked about the variant-aware dependency management. That would be for us the next big step when it comes to dependency management, which is also super important for the whole multi-platform story. In Java, without variants, you somehow get by, although it gets more and more painful. When you don't have variant-aware dependency management in the native world, it's pointless. You can't do C++ dependency management with POMs, right? It's just not rich enough, right? You need to be very precise which variant you need for which, depending on the architecture of your platform and whatnot. So the same is true for Android. So there's a lot of cool stuff to come. Okay, the last thing I want to talk about is build infrastructure management, right? So who of you is using already Gradle? Okay, so So for those, this is nothing new in here, but for those who don't know Gradle, it's a very, well, there will be something new, but not some of that won't be new. So let's start with the Gradle wrapper. So in Gradle, we have the concept of a wrapper task. In the later versions of Gradle, you don't even need to specify that task. What this task does, if you execute it, if you execute the wrapper task, that is usually done by the build master, right? The wrapper task will create a couple of files in your root directory, right? A Gradle W, a Gradle W bat command, and a Gradle directory with a wrapper directory that has a Gradle wrapper jar, which is a few kilobytes, and Gradle wrapper properties. So, and what you now do is you commit all those files to version control, right? And then your people at your organizations, they don't need to install Gradle. They can use the Gradle W commands, and then, as specified by this distribution URL, they will the Gradle distribution will automatically be downloaded. So this is a really, really helpful feature for two reasons. First of all, it means zero administration on the client side, right? Your developers don't have to bother about installing build systems. Second is, so actually there are three items to mention. Second is that you have now the version of your build system nailed down in version control. So this is super important for reproducible builds, right? When you want to do a build that is 1 year old. We have organizations using Gradle that are in the medical device business. So if they get an audit, right, and if they can't show that they are still able to rebuild the binaries that they have put on devices they already sold to hospitals, they have to call back the devices, right? So for them, reproducibility is a super important story. And the third thing is support, right? You don't get these calls, oh, my build is not working with a certain version of Gradle. You say, well, I don't care, use the wrapper. This is the canonically supported version. So so the quality of service of your build infrastructure will increase. Okay, so the next thing I want to show, and and both I will show at the end how they play wonderfully together, are init scripts. So what you can do with Gradle is that you we have here a simple Java project. It's called testing with Gradle, right? And what I want to do now, I want to take some information out of that build. For example, the place where to retrieve the repositories, the dependencies from, right? So if I would run this build, it would fail. Gradle would say, I have no idea what repository, and Gradle has a repository aware dependency resolution, so that build wouldn't work. And what I want to do now is I want to inject this information from a different plugin. We call
Change it to a good one.
Yeah.
On the way.
When you do the screen recording for me of the new. So I have created what we call an init script. It's a kind of plugin where we will now say repositories should be Maven Central, right? Okay. So. And we now execute the testing with Gradle project. We run the tests, and we inject this init script. And what we see now is that the build is working, that Gradle has a nice dynamic console output, and everything is fine, right? So this was not a very spectacular example. It's almost like a source include, right? This snippet where to retrieve the dependencies from, but those init scripts are super powerful. Let's come up with something more exciting. Let's say you want to inject the following behavior into your builds. Issue a warning in real time if any test method you are executing takes longer than 20 milliseconds. How can we do that? So we go to this init script and we say, and this is a plugin where you can fully hook into the Gradle runtime of the build that you are injecting this init script into, and you can say, hey Gradle, after you've evaluated all the builds of this project, right? Give me all tasks of type test, and I hook in a listener into this test task that gets called after a test method is executed, and I calculate the time it took to execute the test. And I then issue a warning if the build time takes longer than 20 milliseconds. Again, that's something you wouldn't write directly in your build script. You would put that again in a plugin, right? That is, but okay. So and you can now run the build with this init script, and you see that in real time, you now get the warnings, right? So it shows you a couple of things. First of all, Gradle has a deep API, right? You can put all different kind of stuff in this init script. You can say, okay, I want to check whether any of the repositories, right, that are used are internal repositories, are approved repositories. So, and you might say, on development, developer can use whatever repository they want to use, whatever snapshot repository, whatever public repository for doing their experiments. But everything that is committed and is built on CI should only use approved repositories, right? And so with an init script, you can inject this behavior into all your Gradle CI builds and check whether the repositories that are declared in the build are correct. So, and again, we're now back to the rich model story from the beginning, right? How you can easily use the rich model to make some very powerful checks or some very powerful extensions, right? So, the last thing I want to show you is every Gradle distribution has an init.d directory. So I can go to the local Gradle distribution, and it's empty by default, but put such an init script in this init.d directory, and I copy the content of the init scripts we have explicitly injected on the command line. By the way, you can inject as many init scripts you want. So I have now created this init script in init.d, and now I can run my and now for every build that is run with that Gradle distribution will automatically apply this init script. So again, we would not encourage developers to change their local Gradle distribution, but now we're back to the wrapper. You can create your own organization-specific Gradle distribution by taking a Gradle distribution and putting all your stuff in the init.d directory, right? And then you specify the URL to your Gradle distribution with all your init plugins, and that way you can provide your developers fully pre-configured build environment for your organizational needs, with all the checks you want to have, with standard repositories that should be used, with, for example, all the dependency rules that you may define. So this is super powerful for provisioning a build environment. And again, it's all in version control because the wrapper properties are in version control. Yeah, there's other things we offer in Gradle that you can specify other parts of your build environment in the project directory. So you can have a Gradle properties file where you can specify the JDK that should be used for the Gradle build itself, the JVM arcs for those Gradle build. Again, I don't want to have a build wiki where developers have to read, oh, for building this, you need to set your end ops or your Maven ops or your Gradle ops to that value. This is something that should just work. People shouldn't have to look that up in a build wiki. It should be version controlled to have also reliable historical builds, etc. Right? And as you can see, with the Java component model, I've shown you where you also specify the Java versions that you're using. More and more of your build environment will be in version control and will not depend on what is installed on the local machine. So basically our goal is to capture the whole build environment and the whole tool chain that you need to build your artifacts with Gradle in a declarative way, so that it's version controlled, that it's fully reproducible, and yeah, we get there incrementally. But it's you already get a lot right now out of that. Okay, any questions? Yes, please.
Do you have any plans for Scala support?
Do we have any plans for Scala support? Gradle has decent Scala support, and we're now working with LinkedIn to make that even better, and to also add Play support. Yeah, Scala is a first-class citizen, basically. Yes, Andres.
I got a question regarding the variants. So you said that POM files are not good enough for defining all the different variations and the richness of variants and products and whatnot. You have shown how easy it is to consume it.
Mm-hmm.
How can you, is there a need for a different metadata file to produce this in order to be consumed for another build?
Yes, so is there a need for another metadata format to model variant? Definitely for the native world. 100%, yes. And also for the Android world, I think.
So are we going to see the next version of
That's, well, I mean, we will always support POM files, and we will try. So the key thing is that Gradle has a rich model about variants, and then you can decide yourself how do you want to persist it, right? And then there will be lossy ways to persist it with the POM XML, but we might provide you some powerful capabilities to still do this in a reasonable way, at least for the Java world, or you say, I use a better format, right? And for
Is there a better format is coming from you?
yes, yes.
Big announcement.
Well, yeah. It's for us. That's not the key. The key thing is the model, right? The key thing is the model. However you persist that, you can come up with your. You will easily be able to plug in your own custom format. For us, this is not. This is a derivative. How you persist it, right? It's almost boring. So the key thing is the capabilities inside, right? That is the, and then the rest is just replaceable. Yes, please.
Are there any Gradle best practices or tools to support versioning and releasing versions through your CI?
Yeah. So, are there any Gradle best practices for releasing versions through the CI process? So there are a couple of plugins out there, a couple of Gradle release plugins out there that do some reasonable stuff. It's still something where we don't provide yet the richness of abstractions we want to provide for that field, right? So Gradle is powerful to model your requirements, but we don't provide you yet this kind of super high level language to easily express all those needs. So you have to do things a little bit more low level, and so in terms of best practices, there's nothing that comes out of the box with Gradle for that. Just a powerful toolkit to model it. Then there are some external plugins that provide you some of that, but we want to make this much more a core concept. And you with the component selection rules, those are the tools, right? And now the next thing is to build higher abstractions on top of that, where you can express things more easily than doing things low level, like using component selection rules. Yes, please.
Do you have any advice for moving complex Maven builds into Gradle?
Yes. So usually it's pretty straightforward, right? So first of all, there is a POM to Gradle converter. So you can say convert my POM XML to a Gradle build file. What we won't do is we can't. Your custom Maven plugins are not converted, right? So those you have to migrate manually. But usually it's pretty straightforward. Complex AND builds are much harder, right? Usually that's. I mean, it depends what you're doing, but complexity can mean two things: breadth, just big, many submodules. That's easy. And then it can mean depth. You have 100 custom Maven plugins, right? You need to migrate, right? So then becomes more work. But usually it's even those Maven plugins, to convert them, it's straightforward because Gradle has such a rich model, right? You can easily replace what you did with the POM model with the Gradle model. And you might get rid of some of the custom Maven plugins because it's just out of the box behavior you get with Gradle, right? Like the Maven Enforcer plugin. Goodbye Maven Enforcer plugin. Yeah. So. Yes.
In terms of native support, is there some guys interested in like iOS builds
Yes, so there are. So that is an interesting topic. So you can do Objective-C with Gradle right now, right? So Objective-C is supported. But what we have at the moment is external plugins that wrap around Xcode if you do iOS development, and it's still something we're considering. What is the best approach? At the moment, we don't have any bandwidth, but we have to see how we tackle that. We would love to tackle it as deep as the other platforms, but it's a very closed kind of ecosystem. So let's see. Yes, please.
Do you have any advice for migrating complex hand builds to Gradle?
Yes. So the key thing is when migrating, do it in baby steps. So when you have this end build and you think, now I can do all this cool stuff with Gradle, I can refactor the code base and restructure. Don't do this, I would say, initially, right? Put the Gradle build in exactly in the production branch where your end builds lives. Gradle is flexible. It can adapt to whatever terrible or not terrible input structure you have, right? Don't change the physical structure of your build, right? Of your Gradle of your Gradle experiment. Use exactly the same thing you're using for your production end build, and then write tests. Tests in terms of Gradle tasks that check are the archives that are produced by Gradle exactly the same as produced by Ant? Are the tests that are run exactly the same? Is the Java doc the same? Whatever output you have with Ant, write a test that compares, is Gradle doing the same? Because when you have a complex Ant build, it will take some weeks to migrate it, or maybe even more. So this is a moving target, right? So you want to be sure that everything is in sync and stays in sync, and then you build up the functionality. Try to compile, try to test, build the jars, and then one point when you have all the functionality that the Ant build has and the tests are all running, then you set your Gradle build live, and then you do the next steps. Right. So we have organizations that were using .classPath at their dependency metadata format and putting this in version control. I mean, it's what can you say, right? But still, I said, don't move to Gradle dependency management right now. We can import the .classPath file and can interpret it for Gradle dependency management, right? And first, get it production ready, and then do the next step. The next step is get rid of .classPath, use Gradle native dependency annotation, and so on and so on. So that's my recommendation, and hope that the person that created the end build is still around. Okay, time is over. Thanks a lot.